Nested loops are the natural continuation of loops. Nested loop is basically a loop within a loop. You would need to use nested loops when you have more than one varying element or when you want to go through a matrix and perform more complex operations on that matrix. With a single loop you can loop through a vector. With two nested loops you can loop through a matrix. Each of the iterators of the loops will represent each of the dimensions of that matrix. So let's see a very simple example. Let's say that we want to generate a matrix and that matrix should be 10 by 10, so 10 rows, 10 columns, a square matrix, and the first row will be of ones, the second row of twos, the third row of threes, and so on. So each row will have a different number. There are many ways in which you can accomplish this, so let's see a few examples. This is purely for practicing how to work with nested loops. Now, let's generate a matrix of zeros first. So matrix of zeros of 10, so 10 by 10 matrix. And let's create a for loop. The first for loop, this is the outer for loop that we are going to create. The outer for loop will have an indexer equal to from 1 to size of the matrix of the first dimension of the matrix. We are doing it like this because if we later change the matrix and make it a non-square matrix, for example with 5 rows and 10 columns, this will automatically be reflected thanks to the size function. And we are going to end. Inside the for loop we are going to create our second loop, which will be with a different indexer. In that indexer will be from 1 to size of the matrix of the second dimension. And first let's see what will be the actual values of these two loops before we move on to the matrix. So if we run it like that, we should get a vector generated with the values of each of the loops. So let's run it and observe. Now if we go back to the beginning, we can see the following thing. The first value is I, the second value is j. The first value is from the outer loop, the second value is from the inner loop. What we observe here is that the first value is always 1 until the second value reaches 10. So both of these loops run from 1 to 10 since this is the size of the matrix. For every one iteration of the outer loop, the inner loop will iterate 10 times. So whatever is inside this loop will be executed 100 times. As you can see here, our inner loop executed 10 times, our j reached 10, but the I still stays at 1. The I is still a 1. After it reached 10, we got out of the inner loop and we got back to our outer loop. The outer loop I now became increased by 1. It takes its next value. It takes its next index, which is now 2. And the inner loop starts re-executing again and again and again and again until it reaches 10. At this point, the outer loop will increase again. Then we have another 10 loops for the inner loop. Then the outer loop will again increment by 1 and so on until all combinations between these two loops are completed. To use these loops to iterate through a matrix, we can say the following. If we want to work on the matrix row by row, we can say matrix of I and j. What we are saying here is, since for 10 iterations of the inner loop, the outer loop stays with the same value, we will use the outer loop indexer for the row. So this stays 1 and this changes from 1 to 10. So we go through the whole first row and we will set it equal to I. Now, this alone should generate the matrix that we wanted. Let's run it and see it. Let's run it. And there we have it. So let's go through this one more time. We start the loop. Our I is initially equal to 1. This is I. This I is here, so we have matrix of 1. In the first iteration, j is also equal to 1. Matrix of 1 and 1 is our first value. We set I equal to that is our first index. We set I equal to that first index. I is 1. Then our inner loop reiterates. Now j is equal to 2. Now we are addressing 1 and 2. We are addressing the second element from the same row. Once is 1. We're saving again the same I value to that element. And we do this for all of these values. We have 1, 3, 1, 4, until we get to 1, 10. And we are saving the value of I on for each of these elements. At this point, the inner loop has completed its job. We go back to our outer loop. Now I becomes incremented. I is now 2. It's no longer a 1, so it's 2. And now we start addressing matrix of 2 and 1, 2 and 2. Basically, these two loops allow you to go to the matrix row by row like this. First row. Then you go back and you start on the second row. You go through the whole row, you go back and you start on the third row. You go through the third row, you go back until you move through all of the rows of that matrix and move through each of the elements of the matrix. That way you have now moved through the whole matrix row by row, element by element. This is how nested loops work. If we change the matrix to 5 by 10 now, we will get a 5 by 10 matrix. If we change to 10 by 5, we get a 10 by 5 matrix. And this is still working.